Hi students, today we're going to talk about lesson 16 in your workbooks. So if you don't have it open already, go ahead and open to lesson 16. We're still in unit 5. And we're talking about finding cone dimensions. So the first thing we're going to look at is section 2, and it's called an unknown radius. And the section says that the volume V of a cone with a radius R is given by this formula. And this is the formula you talked about in class yesterday. And it's volume of a cone equals 1/3 times pi times the radius squared times the height. And it says the volume of this cone, the cone that you see here, has a height of 3 units and a radius of r units. And V, the volume, is 64 pi cubic units. And they're telling you ahead of time that this statement is true, that the volume, which is 64 pi, is equal to 1/3, I'm going to compare it to this formula here. Volume, they're telling us, is 64 pi, is equal to 1/3 times pi times radius squared, times height, and we know the height is 3. And the question they're asking you is, what does the radius of this cone have to be? So they gave us the volume and they gave us the height, and they want us to tell them what is the radius. So we're just going to do a little bit of math here and figure it out. So first of all, let's look at the right side of the equation. We have 1/3 times pi times radius squared times 3. And we've got a fraction involved here and a whole number. So we're going to put this whole number over 1. And then we can see that we can cross cancel. 3 goes into itself 1 time, and 3 goes into itself 1 time. So really over here we have 64 pi is equal to pi times r squared. And then over here we have 1/1 times 1/1, which is 1 times 1, which we don't need to include in our equation over here anymore. So now we have 64 pi equals pi r squared, and I want to get rid of everything but the radius. So what's with this radius over here? A pi symbol, so I'm going to divide by pi. Now I have 64 equals our radius squared. And because I have radius squared, I need to take the square root of each side, and I get 8 equals my radius. And that's one example. Oh, too close to the edge. That's one example of finding a unit that is unknown when they give you other units. So they gave us the volume and they gave us the height, and we can use that information, plug it into the formula, and find our unknown radius. And when it says, explain how you know, well, I just showed you all the work, and that's explanation enough. So section 3 has cones with unknown dimensions, and it shows a cone, a drawing of a cone, and it says each row of the table has some information about a particular cone. So each row is a different cone, and they want us to complete the table with the missing dimensions. So we're going to start just plugging in numbers and doing a lot of math. And every single one of them is going to start with the formula, volume equals 1/3 times pi times radius squared times height. And in this first row, they gave us the radius and they gave us the height. So I still don't know my volume, and I know it's equals to 1/3 times pi. My radius squared is 4 squared, so that's going to be times 16. And my height is times 3 because they gave us the height. So again, this is like 16/1. This is like 3/1. I can cross cancel. 3 goes into itself once, and 3 goes into itself once. So I have volume equals pi times 16, or 16 pi. So I can fill this in. The volume equals 16 pi. And then it is asking a couple other things. So first of all, it asks, what is the diameter? Well, if the radius is 4, the diameter is twice the radius. So 2 times 4 is going to be 8. Then it's asking me, what is the area of the base? Well, the area of the base in our formula is this portion right here, pi times r squared. So if I can find that here, it's really pi times r squared, which is the 16 pi. So even though it is the same as the volume of a cone, the area of the base is also 16 pi. It's not always going to be the case, but in this one it is. So let's do the same thing again, but radius this time is 1/3 and our height is 1/6. I'm going to use this space up here. So I'm going to start with the area of the cone, or the volume of the cone. Volume is 1/3 times pi times radius squared times height. So again, they didn't give us the volume, so I'm going to keep my variable there. 1/3 times pi, that's a given. The radius they gave us is 1/3. So I need radius squared. So 1/3 times 1/3 is 1/9. So I have 1/9 for my radius squared. And then they gave us the height of 6. So this is like 6 or 6/1. And I can cross cancel. 3 goes into itself once. 3 goes into 6 twice. So if I can see what I've got here, I've got 1 times pi. So I've got pi times 1/9 times 2, or 2/1. So if I clean this up again, I've got 1 times 2 is 2. 9 times 1 is 9. 2/9 pi is my volume. So let's go over here. 2/9 pi is my volume. And then they asked, what is the area of the base? Well, again, the area of the base is this pi r squared. And that is right here, pi r squared. So it's 1/9 pi. And then what is the diameter? If the radius is 1/3, I need 2 times that, or twice that, which is 1/3 plus 1/3, or 2/3. Okay, I'm going to continue with this one. They gave us the area of the base and the height. So in my formula, I've got volume equals 1/3 pi r squared times height. The area of the base, again, is this pi r squared. So that's what I'm going to replace with 36 pi. So here it is. So I've got volume equals 1/3 times, instead of pi r squared, I've got 36 pi. And then they gave us the height of 1/4 times a height of 1/4. All right, so this again is like 36/1. So I can cross cancel. 4 goes into itself once. 4 goes into 36 9 times. Then I can cross cancel this 3 and 9. 3 goes into itself once, and 3 goes into 9 3 times. So on my denominator, I have 1 times 1 times 1. So the denominator is now non-existent. In my numerator, I have 1 times 3 times 1. So I have 3, and then there's that pi symbol. So I have 3 pi for my volume. So I'm going to fill that in, 3 pi. And then they said, well, what is my radius? Well, I know that the area of the base is pi times radius squared, and they gave us that, and they said it's 36 pi. So I need to find out what is the square root of 36, and that will give me what my radius is. The square root of 36 is 6, and I know that my diameter is twice the radius, which will be 12. Okay, in this next one, they gave us the diameter. Well, I know the diameter is I know the radius is half of the diameter. So if the diameter is 20, the radius is 10. They did not give us the area of the base, and they did not give us the height. But we can figure out the area of the base, because the area of the base is pi times the radius squared. And we know the radius is 10. So 10 squared is 100 times pi, and that is the area of the base. Now I just need to find the height. So again, I'm going to use that formula. Volume equals 1/3 times the area of the base, which is 100 pi, times my height. Oh, I'm sorry, they gave us the volume. So instead of the volume, it's going to be 200 pi. So the first thing I'm going to do is get rid of this fraction. To get rid of the fraction, I'm going to multiply by 3. So I'm going to multiply both sides by 3, or 3 over 1, and I'm going to get 600 pi equals 100 pi times h. And I'm looking for my height, so I'm going to divide by 100 pi because I have to get rid of everything that's on the same side. And because the 100 pi is being multiplied times my h, I'm going to divide by 100 pi. Whatever I do to that side, I have to do to this side. 600 divided by 100 is 6 equals h. Pi's cancel each other out. This turns into 6 over 1, or 6. So my height over here is 6. I hope I'm not going too fast for you guys. If I am, please feel free to pause the video as I go through. I have to tell you, doing things like this is really fun for me because I like to manipulate numbers and do different things with them. So if I am going too fast, I apologize. So the next row doesn't give us the diameter, the radius, or the area of the base. It only gives us the height and the volume. So again, volume is 1/3 times pi times my radius squared times height. So I've got 64 times pi is my volume equals 1/3 times pi times my radius squared times 12 for my height. Once again, I can cross cancel because it's like 12 over 1. So 3 goes into itself once. 3 goes into 12 4 times. So let's see, what do I have? I have 64 pi equals 1 over 1. So I've got pi times radius squared times 4. So I can divide by everything except the radius squared because that's what I need to get. I can divide by pi and I can divide by 4 over here. Same thing, divide by 4 and divide by pi. And what happens over here, I've got pi divided by pi is 1. 64 divided by 4 is 16. And then over here I have my radius squared because these cancel each other out. So I have 16 equals radius squared, take the square root, and I get 4 equals my radius. So let's fill this in. I've got 4 equals my radius. Twice that is going to be my diameter, so that's going to be 8. The area of my base is pi times my radius squared. Well, radius squared is 16, so my base is 16 pi. And then finally, the last one, I have the area of the cone is 3.14, and that's equal to 1/3 times, instead of pi this time, I'm going to use 3.14 because now they're using 3.14 for pi, times my radius squared, which I do not know, but I do know my height, which is 3. Okay, cross cancel, we go, 3 goes into itself once, 3 goes into 3 once, so I have 3.14 equals 3.14 times my radius squared, because this is 1 over 1 or 1, and this turned into 1 as well. Now I divide by 3.14 because it's with my radius squared and I need to get that by itself. 3.14 divided by 3.14 is 1 equals the radius squared. Take the square root. The square root of 1 is 1 equals r. So my radius is 1. My diameter is twice that, so it's 2. The area of the base is 1 squared times pi, which is 1 pi, or just pi. So that's how you find the different dimensions of a cone when you're given 2 of the dimensions. You just kind of have to manipulate the formula and find out which one you need. So let's look at popcorn. All right. So a movie theater offers 2 different containers for popcorn. You can get a cone of popcorn or you can get a cylinder of popcorn. The dimensions are different and the price is different. And they want to know which is the better value. So we want to know which one holds what volume each one holds, and then figure out by dividing it by the price to see which one is the better value. So let's start with the cone. The volume is 1/3 times pi times the radius squared times the height. And they tell us to use 3.14 as an approximation for pi. So I've got 1/3 times 3.14 times my radius. Did they give us the radius? I look at all of this and like, they did not give us the radius. They gave us from here to here is 12. Well, from here to here is actually called the diameter. So the radius is half of the diameter. So I need 6 squared times my height, and the height for this cone is 19. All right, so I have 1/3 times 3.14 times 36 times 19. And this is like 36 over 1. I'm choosing this one because I know 3 goes into 36 an even a number of times. So 3 goes into itself once. 3 goes into 36 12 times. So this really turns into 3.14 times 12 times 19. You can get your calculators out to do that. And when you do that, you get 715.92. So that's the volume of the cone, and you need to take that volume and divide it by the price they're charging. They're charging you $6.75 for that cone. So how much is it for 1 unit of popcorn? I guess 1 centimeter worth of popcorn, it would be 106.06. And then we'll do the same thing for cylinder. The area of a the volume of a cylinder is pi times radius squared times height. So let's start plugging in numbers. I've got 3.14 times my radius. Well, they didn't give us the radius, they gave us the diameter. So the diameter is 8, which means the radius will be 4, so 4 squared, times my height, and the height of this cylinder is 15. So I've got 3.14 times 16 times 15. And when you use your calculators and multiply that out, you get 753.6. You divide that by the price of the cylinder is $6.25, and you're going to get 120.58. So because this is a smaller cost, you're going to get a better deal if you buy the cone versus the cylinder. So which container is better? The cone is better, and this is why. So basically that's our lesson. We see that we've got cylinders with a volume and we've got cones with a volume. And if we know some of the measurements, the volume, the radius, or the height, but we are missing one value, we can plug those values in and see what that missing value is. And please let me know if you have any questions. You're free to email me or ask me in class when I see you again. Thanks, everyone. Have a great day.